Hello everyone. Today we are going to be looking at the journey of an oxygen molecule through the human respiratory system. This is an oxygen molecule. This is how it will be represented during this presentation. This is the human respiratory system. The respiratory system is a collection of organs whose job is to take in oxygen and expel carbon dioxide. An oxygen molecule's journey through the respiratory system begins at the nose. This is where you, the human, breathe in the air containing the oxygen molecule. The air then travels through the pharynx, or throat. Air is not the only thing that travels through the pharynx. Our little oxygen molecule will meet lots of other things like food and water in the pharynx. This makes the pharynx a very special part of the body because it is part of both the respiratory system and the digestive system. However, the pharynx soon splits into two tubes. One goes to the stomach and the other to the lungs. While it would be lots of fun to follow the food and water into the stomach, our job today is to follow the oxygen molecule, so it's off to the lungs for us. Before we can arrive at the lungs, we must pass through a few other places. First, the air travels into the larynx, or voice box. The larynx is what allows you to speak. After the larynx, our little oxygen molecule travels into the trachea, or windpipe. The trachea is basically a nice little passageway for the oxygen molecule. It takes him straight from the larynx to the lungs. But don't get too excited yet. Before we can go into the lungs, we have a decision to make. The trachea branches into two tubes called bronchi. The right tube leads to the right lung, and the left tube leads to the left lung. Either way, we will reach thousands of tiny tubes called bronchioles, which branch off in every direction. Once the oxygen has travelled through one of the many bronchioles, we finally enter the lungs. This is the fun part. Lungs are sponge-like organs that expand and contract when we breathe. This is controlled by the diaphragm, which is the only muscle in the respiratory system. At the end of the bronchioles, the oxygen molecule is forced into tiny little sacs called alveoli. The alveoli are covered in capillaries. The oxygen diffuses into these capillaries from the alveoli into the bloodstream. The oxygen molecule then attaches to hemoglobin, which is attached to red blood cells. The oxygen molecule travels through the pulmonary vein into the heart. The pulmonary vein ends at the left atrium. The oxygen molecule then makes its way down through the mitral valve into the left ventricle. Once inside the left ventricle, the oxygen molecule travels to the aorta. The aorta becomes just an artery after a few centimeters. The oxygen molecule travels through this artery to wherever oxygen is needed at the time. Today, we are going to go to the liver. Once the oxygen molecule reaches the liver, it goes into the capillaries surrounding the liver, where it is then diffused into the liver cells. The oxygen molecule is then used in aerobic respiration with glucose to create energy as well as the byproducts carbon dioxide and water. The now carbon dioxide molecule then diffuses into the capillaries surrounding the liver and then into the veins, which it follows all the way back to the heart. The vein becomes the inferior vena cava shortly before arriving at the heart. Once the carbon dioxide molecule reaches the heart, it enters the right atrium through the tricuspid valve and into the right ventricle. From there, it travels out through the pulmonary artery back to the lungs. Once the carbon dioxide reaches the lungs, it goes into the capillaries surrounding the alveoli, where it is then diffused into the alveoli. Once inside the alveoli, the carbon dioxide travels back up the bronchioles, through the bronchi, through the trachea, larynx and pharynx, and back out the nose into the open air.
Created using Powtoon.